Okay, good evening, everyone. I'm going to start with the land acknowledgement. So, we acknowledge that the lands on which Memorial University's campuses are situated are in the traditional territories of diverse Indigenous groups, and we acknowledge with respect the histories and cultures of the Beothuk, Mi'kmaq, Innu, and Inuit of this province. We encourage everyone to reflect on the lands where you are located and the Indigenous peoples for whom those lands are traditional territory. I'm Neil Bowes, and I'm the Vice President Research here at Memorial University. And I want to thank the many alumni, donors, and friends for joining us to celebrate our wonderful students tonight, who are ready to take their projects to the next level through your support. I'd also like to thank the organisers of this inaugural showcase. And lastly, congratulations to our student participants. We cannot wait to learn about your exciting projects. We at Memorial are incredibly proud of our talented students, and it is my honour to be here and see so many of you, young innovators, who will undoubtedly make our world a better place. So now, it's my pleasure to pass the proceedings over to Kyle Doody, engineer in residence with Memorial Student Design Hub, to tell us more about tonight's event. Kyle.
Thank you, Dr. Bowes. Well, welcome everybody. This is the first annual Student Design Showcase. It's a really exciting event, and thank you all, sponsors, alumni, students, for taking part in it. My name is Kyle. I'm your MC for the evening, and I'm the engineer in residence for the Student Design Hub project. And the Student Design Hub is a new resource center in the Faculty of Engineering that's meant to be available to students in any faculty who are pursuing extracurricular projects so they can go to international competitions, or pursuing new products. So if they're a member of the Entrepreneurship Center, for example, we're there to help them make things as well. So we hope to continue to build the resources we have available for students, and hope to see more and more cool projects happening over the next couple of years. A couple of small housekeeping items before we get going. And forgive me, my inner newfie is coming out, so I'm talking a little fast. Female, male, and non-binary washrooms are just down the hall outside the main entrance. So if you just continue down the hallway a little bit, you'll find the washrooms. In case of emergency and an alarm sounds, we're just going to exit to the left and then muster on the east side of the parking structure. And you'll notice on the tables in front of you, there's some name tags and pens. For the networking event later on, I'd appreciate it if you could all put on your name tags, maybe put down which company or team you're a part of. And then that way it'll kind of help with discussions when we get back to the networking portion. So before we kick off the showcase, at a high level, here's what's going to happen. Each of our 6 student teams are going to come up. They're going to give a 5-minute presentation. And then you, the potential sponsors and alumni in the audience, have the opportunity to ask them questions. So you can ask them anything that you want to know about their project. And then hopefully, after hearing their case, you'll be compelled to potentially be one of their sponsors. After the Q&A session, we're going to actually, before we do that, I'm going to introduce my 2 work term students, Kyle and Ben. They're at the back of the room, guys. You want to just wave your hands there? They helped out immensely this afternoon setting up the room, so I'd like to give them a round of applause, if that's okay. In front of you, there's 2 pieces of paper. There's a QR code sheet, and there's a sponsorship sheet. The QR code sheet actually just has a QR code that'll bring you to the sponsorship package for the 6 teams who are presenting this afternoon. So if you want to learn a little bit more about the teams and what they're up to after the pitch, their contact information is right there. So if you want to just reach out to them directly, you can. We also handed out a sponsorship page. So if you choose to sponsor a team during the event, just check off which team that you'd like to sponsor. And we're just going to use that to try and measure success of the event. And if you're here and you're attending and you're not ready to sponsor, or you're not in a position to, that's totally okay. We would still love for you to just put your contact information down there so we can follow up with you maybe after the event to see what we can do better next time. And last but not least, after the 6 presentations, we're going to take a little break, and then we're going to award the best in show. So there's a ballot table at the back of the room. So everybody at the end of the event, if you could just go to the back of the room, grab a ballot, and vote for which team you thought gave the best presentation. We'll tally all those up, and then we'll award that at the networking portion just after the break around 7:10. All right, everybody. Without further ado, I'm going to introduce our first student team, Paradigm Engineering.
Hello, everyone. My name is Jemana Bobber, and I am the electrical lead for Paradigm Engineering. Paradigm is a student group focused on competing in the Intelligent Ground Vehicle Competition. We are made up of students from Memorial University of Newfoundland and Labrador, as well as the College of the North Atlantic. We have a total of 17 students on our team, and they're across all disciplines. So we have members from mechanical, electrical, and computer engineering, as well as business students. Collaboration between disciplines is crucial to how we function as a team, and it allows us to succeed. Okay, sorry about that. So Paradigm has a long-standing history of competing in design competitions. We've previously competed in 4 Hyperloop competitions with SpaceX, as well as the first Not a Boring competition by the Boring Company, before pivoting to the Intelligent Ground Vehicle competition. Now I'm going to hand it over to Aidan Clark, who is our mechanical co-lead.
So as Jumana said, we're going to be competing at the IGVC, which is an autonomous robotic competition taking place in Michigan in just 2 weeks. So the challenge requires us to build a fully autonomous vehicle and then navigate a course with obstacles and varying terrain in the fastest amount of time. So seen on the screen here are 2 renders of our vehicle. On the left is a render of our full vehicle featuring our Omni wheels and a Z camera as well as the control laptop. And on the right can be seen as our powertrain assembly, which features innovative Omni wheels, which can move in any direction, as well as a high power electric motor. Next, we're going to hear from Andrew Nash, our software lead.
Hey, so if you've ever participated in a student design competition, you know testing is one of the most important things you need to do. So something we identified early on was that we wanted to spend a lot of time building a simulator, especially with supply chain constraints. There's going to be a lot of unforeseen delays in building our robot. So on the right, you can see straight out of the rulebook, that's what the competition map looks like. And on the left, you can see we've recreated it one-to-one in Unreal Engine. If you go to the next slide, you can actually see us driving through the simulator. And this sort of highlights something that's quite different about our approach in the competition than all the other teams. We're really machine learning heavy. You can see on the right, we're semantically segmenting the view of the camera, meaning we're essentially just labeling all the objects. So the robot can understand the environment and can know that, hey, I don't need to cross over those lane lines, they're in green, and I need to drive on that purple concrete surface. And we're actually doing this using state-of-the-art machine learning. This is research that's been published in the last year or two. This is the best it gets. So if you go to the next slide, you can see what is sort of the crux of our approach. In the bottom right, we call this our bird's eye view. So we're using another machine learning model to generate this. And this is sort of the top-down view, like as if you were a real bird looking down on the robot. And using this view that we generate, it's actually really easy for us to pathfind through the competition. This is something that no other team has ever done at this competition. So this is very unique. And if you're interested and it looks cool to you, I encourage you to drop by our booth later and drive in the simulator yourself.
Thanks, Andrew. So as mentioned, we've fully designed an autonomous robot. And as we speak right now, the robot is being manufactured and tested. We're on track to be competing at competition in just 2 weeks. And we think that our state-of-the-art technology and innovative ideas will put us ahead of the rest of the teams.
So our team consistently pushes the bar for our success. Sorry about that. Our team has students coming in who want to refine and apply their skills in engineering problem solving. Funding would allow us to travel to Rochester and have students in Rochester able to mitigate any problems that may arise with the vehicle. This is also our first competition for a lot of us due to COVID. So going in person and seeing how competitions work and actually being there and seeing our vehicle work would mean a lot to us. As well, we thank you. We offer 3 sponsorship tiers, and they all come with different perks. And you can read more about that in our sponsorship package after the presentation. So thank you. We'll take questions now.
Are there any questions from the audience?
Yeah, so in addition to the objects, there's also simulated potholes, which are white circles on the ground that we have to avoid. And then there's also going to be at least one ramp in the competition that we have to safely go over and not obviously fall off of to complete the course. Yeah. As far as we know, yes. Yeah, so great question. Like right now, we were just in the machine shop. So we hope to have this built by end of week, and then testing will start right away.
Software is probably one of the hardest parts of this competition. So everything from gathering training data, getting models, getting people on task. There's a lot of different moving parts of the software challenge. So that's why we spent a lot of time building that simulator. So without the bot even being built, we're able to test about 90% of our software.
So unfortunately, the competition limits us to 5 miles an hour, I think. So they can definitely go that fast. Unfortunately, there's no reason for us to test them at higher speeds. Oh, I'm definitely curious. So I might have an answer for you later. Yeah, so the robot has 3 wheels on it, and those wheels can roll in the traditional direction, as well as have rollers so they can go side to side. So when it goes forward, you spin the back 2 wheels, and then it moves forward. And if you need to pivot, you can spin them all, so it'll spin in a circle. A few of our parts are a little too big for that, so most of it is getting shipped, but there are some small components like cameras and electrical components that we will be taking ourselves.
So I tried just about every single other simulator, and none of them worked as well. Unreal creates the highest fidelity environments and has the best Python APIs for testing our robot.
Awesome. Well, are there any more questions out there? No? Let's give Paradigm a round of applause. Excellent work, folks. So, oh, no problem. Our next team is another Memorial University staple. Let's welcome Eastern Edge Robotics to the stage. Awesome. Let's give Eastern Edge a round of applause. Great presentation, folks. So our next group is a group that formed around this time last year, and they've been working really diligently to launch their new team over the last 12 months. Let's give a round of applause for Robosub.
You can take it off, yeah. I can take it off. Yeah. Good evening, everyone. My name is Mordecai, and I'm the team lead for Man Robosub. Man Robosub is a design team that is building an autonomous underwater vehicle to compete in the Robosub competition, which is going to be held later this year in July. Next slide, please. So for this pitch and presentation, I'm going to be going through it in three parts. First, I'm going to talk a bit about the competition and the tasks for the Robosub competition. And then I'll talk about our team and the progress that we have made. And then finally, I will also tell you what we are looking for and what we need from potential sponsors. Before I continue, I just want to thank the organizers for making me to be the third presenter. It helps me to learn from the first presenters. Thank you very much. All right, next slide. So the competition, the Robosub competition, is a autonomous underwater vehicle competition that asks students to build an AUV from scratch, build the software, build the physical parts, compile them, assemble them, and use that AUV to carry out tasks. Now, these tasks are actually, the interesting thing about these tasks is that they are similar to real-world challenges that the industry faces in the AUV industry. So some of the tasks include passing through confined spaces, following a path that is on the seafloor, being able to identify objects underwater, being able to carry objects, drop objects, being able to submerge and re-emerge at designated locations. So it's a very exciting competition, and students get the opportunity to use a lot of the skills that they learn in their studies, and we're really excited to be taking part in it. This year's competition is going to be held at the University of Maryland in the US, and this will be, hopefully, the first time that Memorial will be represented at this competition. So we're really excited, and we hope that we'll be able to go for this competition. Now, the second part of my pitch, I'm going to talk about the team and the progress that we have made. So we are subdivided into three technical teams. We have first an electrical team, and they are working on the circuitry of the AUV. To date, we have been able to work on our propulsion system, working out the power requirements for our propulsion, and being able to control the speed of the thrusters that we're going to be using for our AUV. We've also done some fail-safe tests. These are tests that we conduct to be able to see that our sensors are working. These are sensors for critical things like our temperature, our voltage, making sure that there are no leaks into our enclosure. So this is what the electrical team has done. Next slide, please. We also have the mechanical team. The mechanical team has done some 3D prototyping in SolidWorks, and we have actually been able to build an inexpensive prototype that you have the opportunity today to actually have a look at, look around and ask questions. And we have also been working on other things such as buoyancy test. Next slide, please. And then we also have the software team. And this is what I call the backbone of our team. The software team is responsible for, number one, designing how our AUV is going to be moving. So that's our navigation system, and also the computer vision system. So being able to identify objects and images that will be underwater and using this information to carry out the task, and also for our navigation. So this is the progress that we have made, and we're still working on this so that we can be able to compete in the competition. Now, moving on to what we need. So essentially, we're looking for about three things. First, we're looking for funds. We need funds to buy the other materials that we need for our AUV. We have some of the components, but we don't have all of them, and we're looking to get more funds for these components. We also need funds to help us with travel, because the competition is going to be in the US at the University of Maryland. So that's what we're looking for. Secondly, we are also looking for sponsorship. Now, sponsorship can be in the form of funds, yes, but we're also looking for sponsorship in kind. So if anyone has any of the components that we're using and they're able to donate, we're also looking for that. We're also looking for sponsorship in the sense that we also need to transport our vehicle from here to the competition. And we would like to do this without having to disassemble our parts and then put it together again. And then finally, we are also looking for mentorship. Fortunately for us, we have been able to get mentors for our mechanical team and our electrical team, but we still need mentors for our software team. So for the development of our navigation system and of our computer vision system, we also need mentors to help us with that. So those are some of the things that we're looking for. Next slide, please. This is our sponsorship structure. We have broken it down into tiers. So we have one level, the bronze level, we have a silver level, we have a gold level, and we also have a platinum level. And this just depends on the amount of commitment or the amount of funds that we get from the sponsors. And this would determine what we would do for them in return. So with that, I would like to conclude the presentation. Thank you very much for your attention. If you have any questions, I'll be free to field them. Thank you.
Any questions in the audience for Robosub?
Okay. Thank you very much for your question. So this is a competition that's actually been ongoing for the past 25 years. And it started in 1997. Last year, they had about 53 participants. They had participants from all over the world. So you had participants from Europe, from Asia, even from Russia as well, many places. This is the first time that we as Memorial University are hoping to go there. Yes. Thank you. So we are not disillusioned that this is our first time competing in this competition. We know that obviously there's a huge learning curve in terms of undertaking this, but we are hoping that in this competition that we're going for, we have set some goals on what we want to achieve. For example, although we have to carry out some tasks, there are other deliverables that we have to make for the competition, like design reports, presentations. And we are hoping that we can place in the top 5 of at least one of those technical requirements. I think that's a good goal for us, seeing that it's our first time competing at this competition. Yes. So for navigation, what we are planning to do is to use input from our computer vision system. So we are planning to get the video feed and image feed from our computer vision system, and then use these images to give us position estimates of where we are and where we want to go, and then use what we call go-to-go behavior to go to where we want to go to our location. So this is what we're currently trying to implement, but we would welcome any support in terms of mentorship. If there are any other systems that we can use, that would be very helpful. Yes. So currently, like I said, we have an inexpensive prototype. The good thing about this prototype is that if we really, it's not very stiff, but if we stiffen it up, we can actually use it. Although we are hoping that we can get more materials. Like for example, we're using, for our frame, we're using PVC pipe. That's something that can be used, but we would hope to use something like aluminum frames. So we actually have the frame made up. We have the enclosure attached to the frame. We have some of the thrusters attached to the frame, and you have the opportunity to actually see that today when we go to the design hub space. Some of our team members will be there and they can explain some of those things. Yes. Sorry, could you come again, please? Yes, we are. We need. We still need some components that we're going to use for the competition. Yes. Yes, we do. Yes. We have that in our sponsorship package as well. Yeah.
All right, well, let's give a round of applause for Robosub. So before I introduce the next team, folks, I just want to make a note. Apparently, we're having some issues with some of the QR codes on the handouts there. So I apologize for that. It works on some devices for some reason, and others for it doesn't. So if there's a sponsorship package that doesn't work for you, please just contact me or leave a note on the sponsorship form, and I will email anyone that you want to look at directly to you. And I apologize for that inconvenience. So next up, I want to introduce another one of our new teams, which is going to the competition next week. That is FMUN 10th. Just bear with us for 1 second, folks.
Sorry. Oh, sorry, I'm short. And now I can hear myself. So the thing that we want to do is compete in the F1 10th competition. So first of all, let's talk about who we are. You met us three, but there's also some other very lovely people on our team. We have Victory, we have Success, we have Ryan, we have Marcus, and we have Stefan. So F1 10th is an autonomous race car competition. The idea is essentially for each team competing to build and, most importantly, program the fastest race car. So the idea is that it's a Formula One vehicle, 1/10 the size. Haha. So yeah, so the idea is to build the fastest one. We really like this. We thought it'd be a really interesting challenge to tackle because the kind of challenge that you're tackling, it's autonomous control, and we don't really get to do that a lot in our coursework. It's a very new topic. It's growing very fast, and the most you can do in our program is, a course or two very late in the program. And a lot of people want to learn about it now. A lot of people want to try new things and try and learn about it. It also is a really good way to gain practical experience and the like. So, as Kyle mentioned, we've already started. So let's get to know our car. So we actually did successfully build an autonomous car. It is currently racing, moving, doing pretty good. And this is what we've got. Here's Kyle will show you an example video of it. And that was it going on its own. So yeah, why are we seeking funding? So we would like to travel to the competition. It is an international competition. It's usually located at different international robotics conferences around the world. For example, this year was at the ICRA, the International Conference for Robotics and Automation. So not only do you get to actually go to the competition, you get to go to this really cool conference where there's a lot of other similar things in that area happening that you can learn about. So we are looking to travel in 2023 because we are looking to travel in 2023 because we were having trouble with funding, hence events like these, and we want to make sure we're as prepared and ready for it as possible. This is our budget. You can see the table here. Long story short, so far from the Student Life Bureau Fund, we've thankfully gotten a little under half of our funding. And so we're seeking the other half, which is looking at about $5,000. Of course, sponsorship, it's usually a two-way kind of deal. So I bet you never really quite imagined that you could see your logo on a Formula One race car. But I'm here to tell you that that's possible, just at 1/10 the scale, but also probably 1/10 the price. And that's basically everything. So you can contact us at our email there if you'd like to find out more. And that's all.
Any questions out there for F1 10th?
Hello. Both. So there's two kind of components to it. It's a time trial. It's like Mario Kart. It's time trialed and it's also head to head. And there's different. Sometimes it's a clear track. Sometimes there's obstacles. There's one challenge of just getting around the track, but then there's also the challenge of not hitting other vehicles, which is a big one for autonomous cars. Hello. The idea behind it is, so we've been trying to go two ways with it, which is we'd like to hopefully get another capstone team because they're sort of in the process of, the next term sevens are in the process of selecting their projects now. So we're hoping to see if there is a group of term sevens who'd like to continue the project. And then as well, myself and my other co-team lead, Ryan, we both agreed to try and help mentor because we had an incredibly long learning process in how to just build this kind of a system and think about this kind of subject that, like I said, we don't really get to learn. So next year's team doesn't quite have that challenge. We'd like to be able to kind of mentor or at least be available to help teach everyone about here's what we built, here's how it works, that kind of thing. Hello. Yep. So we were trying a bunch of different approaches, both of which you just listed kind of were the same approaches, were some of the approaches that we tried. So one of the ones that we did try actually was approaching it based on how an actual Formula One driver would do it, which is basically trying to decrease the amount of turning time as much as possible. So it's like you stay really close to one edge and then you take a really sharp turn and then you keep going. So it's meant to minimize the amount of time turning. So yes, long story short, yes. Hello. Sorry, could you repeat that? Not on, yeah, sure.
I was just gonna say, so the rules of the competition is you have the track and there's some obstacle, but like all of them are just static, like they're not moving. So the other obstacle that might be moving, the other cars, they're also racing the same track. But again, it's considered like by the algorithms and stuff we're using, it's kind of considered as an obstacle as well. But yeah.
Hello. It's interestingly enough, a lot of the test tracks, like they give you examples of the tracks, a lot of the test tracks are actually just other university hallways. So you can actually find so there's a way of simulating the car as well, which we did for testing algorithms before we had built the car. And a lot of the test tracks are actually just, it'll be insert universities here, second floor hallway. So luckily for us, it's actually been pretty easy to test. So we've run it around the basement hallway in the engineering building. And as well, we've taken large strips of cardboard to kind of use. That's what you were seeing in the video there, and just giant strips of cardboard to test it that way.
The cardboard pieces, like they imitate the actual competition track, because we got the dimensions and everything from their website, and we tried to build like a similar track in terms of the height of the barriers and like the obstacles and everything. So yeah, we think we had a pretty good testing done on it.
Hello. I don't think, off the top of my head, I don't know. It's something like that. It depends on how you configure the motor and you actually configure the physical gears of it, in which we're mostly focusing on software and the electrical side of things. And so I think I knew at one point, I don't know now, I'm sorry.
Just one more thing, in terms of like the actual testing that we've done, we weren't able to like measure the full speed of the car because of how short the track we were testing with, like on the cardboard and resources we had. But in terms of like turning angles and stuff, yeah, that's what we said. But we still like we don't have an idea of like the maximum speed it can go because that depends on turning and obstacles and everything.
So we're also kind of limited to the track system we use because I think they give us a specific track system to use for the base of the car, and so it just goes based on the range in which the front wheels can turn. So those are kind of the range that we can work with.
All right, folks, let's give it up for F-Mon 10. Great job, folks. So our next team is also a recent pop-up. They started about 4 months ago, and they kind of grew out of an interest in project for the aerospace industry. Let's welcome Phoenix Aerospace.
We'll try and squeeze everyone in. So hi, everyone. Thank you all for coming tonight. We're a new team, and we are Phoenix Aerospace. So before we begin, a quick rundown of our agenda. We'll first introduce you guys to our team and what we do. Then we'll discuss our progress and where we are and how you guys can help us. And we'll finish off with some questions. So my name is Aaron Parsons, and alongside of me tonight is Hussein, and we are the team leads. And also Mo, he's another team lead, but he couldn't be here tonight because he is in Ontario. We have 5 subsystem leads. We have Matthew, he's our design lead. We have Yahya and Laith, they are our software lead and co-lead. And we have Chloe, she's responsible for marketing. And we have Aaron, he is our electrical lead. So a little bit about who we are and what we do. We are the first and only aerospace club at Memorial University, and we're relatively new. We just started in January 2022, but we have about 40 members, which is really great. And the reason why me and Hussein and Mo kind of started this club was to give students a bit of exposure to the aerospace industry and to make connections with the leaders in the field. And to do this, we are creating our own drone, and we are also working with satellites, which is really cool. Another great reason to join our team is because we have people from a variety of disciplines. We're not just engineering students. We have people in chemistry. They work on research, computer science to help with software, and of course, business. So I'll bring it over to Hussein for the rest.
Thank you very much. Hi, everyone. So our team, we're working on 3 main projects. The first one is obviously the competition, IEEE competition, which is happening in October. The competition is, as you can see, it's a warehouse in the US. It's in an airport. There's going to be a mini city built, and there's a car, small car, that's going to be going throughout the city. The drone would have to, our main purpose is to build the software that will follow that car throughout the endpoint. While the drone is going, there's going to be obstacles, and there's going to be things thrown on the drone. The drone would have to avoid all these obstacles. A little bit like military applications. So that's a little bit about the competition, which we're going to in October, hopefully. The second main project that our team is working on is satellites. So Kilik 1 CubeSat, I'm not sure if some of you are familiar with it. It's a project that Secor is working on with CSA, Canadian Space Agency. They are building a satellite, a CubeSat. It's a mini satellite that the purpose of it is to measure sea ice thickness in northern Canada. Our team was going to be responsible for just communication when the satellite is launched, but right now a little bit some stuff's changed. We are going to be working with Secor for testing some mechanical components and helping with software as well, because their launch date is very close and there's a lot of work that needs to be done. Also, that is good for us because in the future, CSA, they're going to be doing competition with students directly. So Secor won't be responsible for it anymore. Our club will be in direct contact with CSA. CSA will give major components for the clubs, and we would have to work around these components to build the satellite. There's going to be competitions across Canada. The university that will win the competition, their satellite will get launched into space. The third project is building our in-house drone. As I mentioned before, we're going to a competition in October. That competition, they're giving us a drone to compete. We have to build the software to put on the drone, but we have an option to take our own drone. So we're going to take the drone that they're building, that they're going to give us. We are going to make it better and take it with us to the competition. We get more points and we get advantage on all other teams that because we have a better drone. So where we are now, our software team is working on the competition. Our software team, there's about 12 people in it. There's a lot of seniors as well in the team. They are working on developing the software, and they're also helping with the satellite. Our electrical team will be focused on building the drone. There's a lot of electrical components in it, along with the frame. And the design team is helping the Killing One team at Secor, making sure all the mechanical components like hinges and burn wire mechanisms are built and tested. There's a lot of testing and certification required by CSA before the satellite is launched. And the marketing team are helping us for social media and building sponsorship package on the website. That's it. Oh, how you can help us. That's the main part, actually. So financial support, obviously, that's one of the main things. The competition in October, the main funds that we probably will need is total to about $18,000 between travel and building the drone. Along with that, mentorship. As we discussed earlier, we're still a brand new club. So there's a lot of things that we're not sure how to build. A lot of mentorship in that field would be very helpful. Now that's it. Thank you very much. Any questions? So the competition require us to build to go to the competition with specific requirements. So the drone have to be able to avoid obstacles. So there's going to be things thrown at the drone and have to be you have to maneuver from getting hit. You have to have sensors to follow specific object that's moving with a specific LED light color. Our drone, because from what I've seen on Slack, that's the organizer of the competition, a lot of universities across Canada and US are taking the provided drone. We are building a drone. We're taking the same drone because you can go on the website and see what's with that drone. We are disassembling that and building a better one. We're not really buying the drone. We're just looking at what type of sensors used, and we're getting better sensors, and we're building it in a better way with better engines, motors, so it can be a little bit better performance overall. Any other questions? So because we have 40 people, so it's good resources that we have. With building the drone, I built the drone before myself with my brother in 3 months. So building the drone itself, you're buying a lot of equipment, so it doesn't really require a lot of resources. Because of that, we're able to use many resources in different areas. So we have people that are working on the Killik One, people that are building the drone, which is going to be mainly Capstone team that's doing it. So it's only 4 people. The rest will be focused on the Killik One. Somebody, yeah. So I think it's going to be about 9 or 10. Any other questions? Yeah. I think it's going to be a long-term team. There's going to be a lot of different competitions. So, for example, CSA, like I mentioned earlier, they're going to be doing long-term competitions directly with students. So our club is the only aerospace club at MUN. So there's going to be that competition with CSA. There's a lot of SEA competitions as well. Also, another advantage that we built aerospace team. I spoke to a professor before. This might be a route for having an aerospace discipline at MUN. We don't have an aerospace discipline. We have some courses that teach some aerospace, but because there's a lot of interest in our club, there's about 40 people, maybe a little bit more. So that shows that there's a lot of interest in aerospace industry. So that could lead to an aerospace field at the university.
Awesome. Let's give it up for Phoenix Aerospace. All right, folks, you're going to notice that some of our friends in the audience are distributing some ballots. So just remember, we're looking to have a vote for the best presentation and show at the end. So, listen to this last presentation and drop your ballot in the ballot box at the end. Just to note, the students are not allowed to vote for themselves. So we're going to stick to attendees for the ballots. So last but not least, we have one of our Canadian staples, a team that's been around MUN for a while. I'm excited to introduce Concrete Toboggan.
Can everybody hear me? Fantastic. Hi, everyone. I'm Billy Barnes. I'm one of the co-captains and the steering and braking lead for MUN Concrete Toboggan. On my left, I have Grace, one of our concrete leads. And on my right, I have Riley, our other co-captain. Today, I'm going to discuss with you why you should support our team. So first up, what is MUN Concrete Toboggan? It is a student group consisting of over 30 engineering students across multiple disciplines. This includes mechanical, civil, process, electrical, and computer. We've been competing in the GNCTR since 2018, and we're a team full of passionate, innovative, hardworking, competitive, and fun individuals. So now I should cover what we compete in, which is the GNCTR, otherwise known as the Great Northern Concrete Toboggan Race. This is the largest and the longest running student-led competition in Canada. Each year, over 500 engineering students attend and compete in this event. It is a 5-day competition, including technical exhibitions, presentations, and most importantly, racing events, each of which are scored for the competition. This year's, or the upcoming, GNCTR is held in Kelowna, BC from January 25th to the 29th. So what is a concrete toboggan? It's very simple. It's a downhill sled capable of steering, braking, and safely carrying 5 passengers down a hill. The most important part, which you can probably tell by the name, is that every sliding surface and every surface touching the snow on the toboggan has to be made of concrete. As well, it's required to have a roll cage, which we call a superstructure, to protect the riders inside in the case of an accident. Another important part to note is the weight limit. It must be under 350 pounds and adhere to strict safety standards to be allowed to race down the hill. So where are we now? We feel like we have a very good foundation. We've recently recruited. We have over 30 members. We have a basic CAD model completed and preliminary testing also completed. In this model, we have a rigid suspension system, a simple steering system, a manual braking mechanism, and we have also modeled our concrete skis and superstructure. From a manufacturing point of view, we have our superstructure manufactured and various components of our braking and steering systems manufactured. We're working to improve the toboggan from a technological and a safety standpoint moving forward, which is what I'll touch on next. So what is our goal this year? The main goal of utmost importance is to upgrade the suspension, moving from rigid members to shock-absorbing members. That is our main goal from a mechanical point of view. We also want to upgrade the toboggan braking system from a manual system to a manually aided system. As well, we want to improve the safety standards we operate with by performing vigorous safety testing on all toboggan components and be ready to manufacture by mid-September and have the toboggan completely built by late November, which is about a month and a half earlier than the toboggan has ever been completed before. As well, internally, we want to focus on innovation and skill building. With such a long timeline until our competition, it's about 9 months away. We want to focus on letting the engineers on our team get their hands dirty and apply the skills they learn in school in a physical project, get in the lab, and build some of the components that we need. So what is our goal at the competition? I have a nice little acronym here for you, GNCTR. Gain recognition for our competitive student-driven teams, network with industry professionals and businesses at the competition, compete at a high level and improve upon previous performances, test our knowledge of engineering principles at the competition, and gain and see recognition from MUN and Newfoundland at a national level. But most importantly, I should say, we want to win. We have a marked history of good performance at this event, but with the timeline we have and the team we have, we feel like we can win. And we want to show all of our competitors that MUN produces some of the best, the most skilled, and the most industry-ready engineers in the country. So why should you sponsor MUN Concrete Toboggan? In short, it touches on what I just said. You're supporting directly the professional and skill development of engineering graduates moving into the industry. We feel that MUN Concrete Toboggan gives students the bread and butter skill sets they need to be successful right now in multiple major industries, from our design, testing, and manufacturing opportunities. It covers a wide variety of skills and experiences needed today. As well, it's exposure for your company through advertisement before and during the competition. And it's a great opportunity for you to attract potential and future employees. So what will your sponsorship support? So again, we're 9 months out. We have a lot of time. Sponsorship will most critically go towards toboggan hardware, shipping it there, and the materials used to build it. And then next, the technical display and presentations required. So most importantly, these are all the items that are scored at the competition. That's what we're taking care of first with sponsorship money. And after that, anything left over or supplied after that will go towards the travel and accommodations for team members. Our minimum budget is around $14,000, and that'll cover the construction, the materials, and the shipment of the toboggan to Kelowna. So with that, I thank you for your time. Every member of MUN Concrete Toboggan thanks you for being here today. Are there any questions? I think an important part of that is what I mentioned in one of the slides about getting people's hands on the work. So something that we've talked about, me and Kyle Duty, is in regards to some of the components, actually getting students involved to learn the skills to build them. So what I mean by that is students who have no experience with, say, a CNC machine, getting in the lab and putting their hands on that and building a component that's actually used on the toboggan when it's raced in a couple months. And that combined with the actual design and research required to get this toboggan design ready for September, and then the manufacturing process, I'll say, required to get it done from September to November. To us, it feels like that's a proper timeline and that we'll be able to engage everybody appropriately. Yeah.
To add on to that, bi-weekly meetings too. Like we get together every second week and just pretty much talk about what we need to do in the next X amount of time, whatever. And yeah.
Yes.
So this is my first year as concrete co-lead, and I'm super passionate about the design that we are choosing to go with this year because we participated in a concrete competition last year, and our design reached a 77 MPa compressive strength test on its 7-day break. So our plan this year is to use that mixed design with some fibers, and then the top of the ski is actually reinforced steel, and there's a runner at the bottom. So our plan is to incorporate all of those designs to ensure that each of the 4 skis are functioning at the highest caliber.
Yes.
Activities than we did community based. So we involved the students more so. So we had a few bus crawls, we had some recycling drives. We considered a bake sale at one point, but it wasn't feasible because it was post pandemic. So that wasn't a great option for us. But we are always looking to outreach to the community, and where we have this long duration before the competition, that is one of our intentions. Even just company reaching out to different companies, seeing if they would be interested in hosting us as a seminar, possibly.
That's a great question. So we're a pretty new project. We only opened the doors up in February for the design space. So we're in the process of ramping up to have social media right now. I've got 2 great work term students working with me this semester, so that's something we're working on. But the Design Hub doesn't have a big social media footprint right now, so we're leaning into the Faculty of Engineering a little bit to help us there. And hopefully by this time next year, we'll have a bit more of a presence so that folks will know about this event a lot sooner, and we'll have that kind of industry footprint so that we can continue to support students in events like this, in custom programming, in tutorials, and in other opportunities.
I will say Concrete Toboggan does have LinkedIn, Instagram, Facebook, so we can share the handle with you if you are interested. If you do come to the Student Design Hub for a discussion afterwards, our external leads relation is here, so she will discuss that with you guys.
All right, folks, let's give it up for Concrete Toboggan.
Great.
Okay. All right, folks, so that ends the first part of the evening. This is the end of the formal part of the event, so I'd like you all to just take this opportunity to have a look at your ballots, cast your vote for our best in show, and then pass that down to the end. Adam's helping us out by collecting them. Just fold them in half, and we'll put them in that box, and then we're going to tally up your votes. So before we take a little break and head back to the collaboration lab in the engineering building, a couple quick things. I want to put a thank you out there to Jackie Locke and Matt Conway for all their help in getting this event off the ground. Without them, I probably would have been floundering for a pretty long time because this is my first kick at a big event, so thank you to them. I think Jackie's in the room, so can we give Jackie a round of applause? Next, I want to put a big thank you out to the Student Design Hub Advisory Board. It definitely takes an army to help students create and develop this passion for extracurricular projects. Each and every one of them has been instrumental in advising the program so we could get it off the ground, and we're in our infancy and we're excited to grow and help students grow with us. So let's give a big hand to our advisory board. And a special thanks to our chair and co-chair, Adam Keating and Anna Gazine. I've driven them absolutely insane over the last couple of weeks getting this event off the ground. Next, I want to thank all the students who participated. I know that you're in crunch time. Your competitions are coming up in the next couple of weeks for a lot of you. This is a great opportunity for all of you to get some of that public speaking out of the way, get out those jitters, talk to some people. And we're really excited that you took the time to do that. So let's give a round of applause to all the teams who presented. And last but not least, a big thank you to all you in the audience. This event could not have happened if you didn't choose to attend tonight. Whether you choose to sponsor a team or not, your presence here and your support and your questions are absolutely invaluable to all the students. So thank you very much for being here. So with that, I'm going to invite everyone to take a little 5-10 minute break, cast your votes for the Best in Show Award, and then one quick reminder, Memorial still does have a mandatory mask policy, so when we head back to the networking part of the event, please have your masks on, especially when we're kind of milling about in this room. When you're ready to head over, I've got Kyle and Ben in the back of the room. Just guys, wave your hands again. When you're ready to head over to the hub for the networking, just head out into the lobby and they'll start taking people over in groups. I'll collect up the ballots and tally those. And if you are in a giving mood right now, which we hope you are, there's a drop box in the back for the sponsorship forms, but we can also collect those at the end of the night after the networking portion. So again, thank you all very much. And I look forward to announcing our Best in Show in about 20-30 minutes over in the collaboration lab in the engineering building.